Okay, so in this video, we will be doing FE analysis on Ansys Workbench. As you can see, this is Ansys Workbench. In this video, what we will be do is we will be do a static structural analysis and topology analysis. Okay, so the first part would be static structural, and after that, I will show you how to link two studies together or two to three different physics together. Okay, let's move on. First, import the geometry, browse, document. Okay, let's import the geometry. Okay, and let's move on to the model. So basically, any geometry you can make on SolidWorks or either on Ansys or any software. Just you need IGS file, STL file, or step file to upload on Ansys Workbench. So here it is loading. Okay, so let's check the material. Structural steel as it is default material. So in this case, we are using structural steel. And here is our, let's go to the Ansys Workbench. Okay, let's click on our model. You can see this is our model. Okay, let's check on geometry to see the material is applied. Yes, structural steel is applied. Moving on to mesh. Okay, let's take the element size point zero point zero one. Basically, this is 1 millimeter, 0.01, and let's say generate mesh. So as you can see, our mesh is of 1 millimeter. I can also reduce this to 0.1 millimeter. So let's take it 1 millimeter at a time. So the length is 1.5, 15 millimeter, and this you can also draw this on SolidWorks or Ansys geometry part. Okay, so let's apply fix the geometry first, moving on to the fix support and moving on to the face, and this face is fixed and apply it here. Okay, next moving on to we need to insert force. Next again, let's see where is force. Okay, and force is applied at this this edge. So let's apply edge, and the force is in your z component. You can see by here is 300 acting downward. Okay, so this is acting downward, and let's say, and moving into the solution, what we made is a directional deformation. And okay, insert. Let's check stress equivalent 1 minus stress. Let's delete the directional deformation. Let's take total deformation and let's solve it. And here is the percentage. The bar shows the percentage for solving. For example, I am running this study, so there are iterations running at the back end of the software. Okay, I will show you the solution information over here now. So let's see, this is your solution. Iterations are running over here. Let's see equivalent von Mises stress. Since the force is applied on the this edge, so there is maximum stress. Okay, let's see the deformation and okay. Since this end is fixed, so there is zero deformation, and along the side there is a change in deformation as the force is applied in the z direction at the surface. So this will create some tension or movement on this material on this part. So this is your static structural analysis. You can also animate your result according to your need. Okay, so let's click on this play button and this will be animated as you can see. Okay, let's see the animation of equivalent von Mises stress. Since you can see the force is acting along the z-axis and acting on the set, so the only difference in their force is at this face or edge or at this face and face surface edge. So let's close this tab and you can see there is all your static structural simulation is done. And that's it. And in the next part, I will be adding topological optimization to this part.